The Shulba Sutras or Ulba Sutras are sutra texts belonging to the Rota ritual and containing geometry related to fire altar construction, purpose and origins. The Shulba Sutras are part of the larger corpus of texts called the Shruta Sutras, considered to be appendices to the Vedas. They are the only sources of knowledge of Indian mathematics from the Vedic period. Unique fire altar shapes were associated with unique gifts from the gods. For instance, he who desires heaven is to construct a fire altar in the form of a falcon. A fire altar in the form of a tortoise is to be constructed by one desiring to win the world of Brahman, and those who wish to destroy existing and future enemies should construct a fire altar in the form of a rhombus. The four major Shulba Sutras, which are mathematically the most significant, are those attributed to Baudhayana, Manava, Apastamba and Katyayana. Their language is late Vedic Sanskrit, pointing to a composition roughly during the first millennium BC. The oldest is the sutra attributed to Baudhayana, possibly compiled around 800 BCE to 600 BCE, while the youngest content may date to about 200 CE. List of Shulba Sutras: Apastamba, Baudhayana, Manava, Katyayana, Maitrayana, Varaha, Vardula, Hiranyakeshan. Mathematics. Pythagorean theorem. The sutras contain discussion and non-axiomatic demonstrations of cases of the Pythagorean theorem and Pythagorean triples. It is also implied in cases presented in the earlier work of Apastamba and Baudhayana, although there is no consensus on whether or not Apastamba's rule is derived from Mesopotamia. In Baudhayana, the rules are given as follows. 1.9. The diagonal of a square produces double the area of the square. 1.12. The areas of the squares produced separately by the lengths of the breadth of a rectangle together equal the area of the square produced by the diagonal. 1.13. This is observed in rectangles having sides 3 and 4, 12 and 5, 15 and 8, 7 and 24, 12 and 35, 15 and 36. The Satapatha Brahmana and the Taittiriya Samhita were probably also aware of the Pythagoras theorem. Seidenberg argued that either Old Babylonia got the theorem of Pythagoras from India or that Old Babylonia and India got it from a third source. Seidenberg suggested that this source might be Sumerian and may predate 1700 BC. Stahl 1999 illustrates an application of the Pythagorean theorem in the Shulba Sutra to convert a rectangle to a square of equal area. Pythagorean triples. Apastamba's rules for building right angles in altars use the following Pythagorean triples. The same triples are easily derived from an Old Babylonian rule, which makes Mesopotamian influence on the sutras likely. Geometry. The Baudhayana Shulba Sutra gives the construction of geometric shapes such as squares and rectangles. It also gives, sometimes approximate, geometric area preserving transformations from one geometric shape to another. These include transforming a square into a rectangle, an isosceles trapezium, an isosceles triangle, a rhombus, and a circle, and transforming a circle into a square. In these texts, approximations, such as the transformation of a circle into a square, appear side by side with more accurate statements. As an example, the statement of circling the square is given in Baudhayana as 2.9. If it is desired to transform a square into a circle, a chord of length, half the diagonal of the square, is stretched from the center to the east, a part of it lying outside the eastern side of the square, with 1/3 of the part lying outside added to the remainder of the half diagonal. The required circle is drawn, and the statement of squaring the circle is given as 2.10. To transform a circle into a square, the diameter is divided into 8 parts. One such part, after being divided into 29 parts, is reduced by 28 of them and further, by the 1/6 of the part left, less the 1/8 of the 6th part. 2.11. Alternatively, divide the diameter into 15 parts and reduce it by 2 of them. This gives the approximate side of the square desired. The constructions in 2.9 and 2.10 give a value of pi as 3.088, while the construction in 2.11 gives pi as 3.004. Square root's alter construction also led to an estimation of the square root of 2 as found in 3 of the sutras. In the Baudhayana Sutra it appears as 2.12. The measure is to be increased by its third, and this third, again by its own fourth less the 34th part of that fourth. This is the value of the diagonal of a square, whose side is the measure, which leads to the value of the square root of 2 as being. One conjecture about how such an approximation was obtained is that it was taken by the formula, within which is an approximation that follows a rule given by the 12th century Muslim mathematician Al-Hassar. The result is correct to 5 decimal places. This formula is also similar in structure to the formula found on a Mesopotamian tablet from the Old Babylonian period, which expresses in the sexagesimal system, and which too is accurate up to 5 decimal places. Indeed, an early method for calculating square roots can be found in some sutras. The method involves the recursive formula for large values of x, which bases itself on the non-recursive identity for values of r extremely small relative to a. Numerals before the period of the Shulba Sutras was at an end. The Brahma numerals had definitely begun to appear, and the similarity with modern-day numerals is clear to see. More importantly even still was the development of the concept of decimal place value. Certain rules given by the famous Indian grammarian Panini add a zero suffix to a base to form words, and this can be said somehow to imply the concept of the mathematical zero. In commensurables it has sometimes been suggested the sutras contain knowledge of irrationality and irrational numbers. Citations and footnotes. ABCD Plafka, Kim. Certain shapes and sizes of fire altars were associated with particular gifts that the sacrificer desired from the gods. He who desires heaven is to construct a fire altar in the form of a falcon. A fire altar in the form of a tortoise is to be constructed by one desiring to win the world of Brahman. Those who wish to destroy existing and future enemies should construct a fire altar in the form of a rhombus. Sennenbach 1983. 86, 98, 111. Missing or empty, title equals. ABCD Boyer, Carl Benjamin. China and India. A History of Mathematics. p. 207. We find rules for the construction of right angles by means of triples of chords the lengths of which form Pythagorean triages, such as 3, 4, and 5, or 5, 12, and 13, or 8, 15, and 17, or 12, 35, and 37. However, all of these triads are easily derived from the Old Babylonian rule, hence, Mesopotamian influence in the Shulba Sutras is not unlikely. Espestambar knew that the square on the diagonal of a rectangle is equal to the sum of the squares on the two adjacent sides. But this form of the Pythagorean theorem also may have been derived from Mesopotamia. So conjectural are the origin and period of the Shulba Sutras that we cannot tell whether or not the rules are related to earlier Egyptian surveying or to the later Greek problem of altar doubling. They are variously dated within an interval of almost 1,000 years, stretching from the 8th century BC to the 2nd century of our era. The rule in the Apostamba cannot be derived from Old Babylon. Plafka, Kim. pp. 388 to 389. Missing or empty, title equals. Seidenberg 1983. Bryant 2001 to 262. Seidenberg 1983, 121. Joseph G.G. The Crest of the Peacock. The Non-European Roots of Mathematics. Princeton University Press. p. 229. ISBN 0-691-00659-8. AB Plafka, Kim. pp. 388 to 391. Missing or empty, title equals ABC Plafka, Kim, p. 391. Missing or empty, title equals AB Plafka, Kim, p. 392. The circulature and quadrature techniques in 2.9 and 2.10, the first of which is illustrated in figure 4.4, imply what we would call a value of pi of 3.088. The quadrature in 2.11, on the other hand, suggests that pi equals 3.004, which is already considered only approximate. In 2.12, the ratio of a square's diagonal to its side 1 equals 1.4142. Missing or empty, title equals ABC Cook. The Mathematics of the Hindus, p. 200. The Hindus had a very good system of approximating irrational square roots. 3 of the Shulba Sutras contain the approximation for the diagonal of a square of side 1. We can only conjecture how such an approximation was obtained. One guess is the approximation with r equals 4/3 and r equals 2/9. This approximation follows a rule given by the 12th century Muslim mathematician Al-Hassar. Line feed character in quote equals at position 336. Missing or empty, title equals Neubauer and A. Sachs. 1945. Mathematical cuneiform texts, New Haven, Connecticut, Yale University Press, p. 45. Boyer, China and India, p. 208. It has been claimed also that the first recognition of incommensurables is to be found in India during the Shulba Sutra period. Missing or empty, title equals